Okay, hi again. So this video I'm going to start talking to you about Kc, which is the equilibrium constant. I'll probably do a couple of videos on this because there's a few different calculations that you need to be able to do. For those of you who aren't as happy with the kind of maths bit of chemistry, I want to make sure that you've got an explanation of how we're calculating all of those things. Now, the Kc, the equilibrium constant, is a constant, but it is temperature dependent. So when you're stating an equilibrium constant, it is for a reaction at a particular temperature. Okay. Now, Kc, equilibrium constant, is the ratio of the concentration of the products to the concentration of reactants at equilibrium. It's really key that you remember that those concentrations are at equilibrium, and you'll quite often have to calculate those concentrations at equilibrium. The units of Kc are different depending on the reaction. So this first bit of the video, I'm going to just go through how we work out units. So first of all, you need to learn how to construct equilibrium, a Kc expression. So let's start with the reaction that we had before. A plus B is in equilibrium with C and D. Nice, easy, straightforward reaction to start with. Now, Kc is the ratio of the products to the ratio of the concentration of the products to the concentration of reactants. So you need to remember to put all of your different chemicals in square brackets if you're talking about concentrations, not round brackets. It has to be square. You'll get penalised, or you could be penalised in your exam if you use round brackets. So I'll show you. Kc is equal to the concentration of the product. So C, D, so C times the concentration of C times the concentration of D divided by the concentration of A times the concentration of B. So that is the Kc expression for this equilibrium, for this reversible reaction. Okay. The reason that we calculate Kc is because it's essentially it's working out the effects of those different conditions, but mathematically. So once you've got a value for Kc, you can use that value to work out to what extent you would increase your yield by changing different conditions like pressure or temperature. So let's look at the units in this case. So I hope that you all know that the units of concentrations are moles per decimeters cubed. So all we have to do is put that into this expression, or just the units, moles per decimeters cubed times by moles per decimeters cubed divided by moles per decimeters cubed times by moles per decimeters cubed. And then you just cancel everything down and see what you're left with. So moles, decimeters cubed, moles, decimeters cubed. In this case, everything cancels, and Kc, in this case, has no units. Okay? So that's the first example I have for you. Now I'm going to do another one. So no units at all. It would simply just be a number. Okay, so the second one we're going to change, and we're going to have our reaction is going to consist of 2A plus B goes to C plus D. So we construct the Kc expression exactly as before, except from the molar coefficients become the power, so the power that this reactant is raised to. So if I show you A raised to the power of 2, so A squared, hang on, I've done that completely wrong. Products first, remember. So we've got C, D, not raised to the power of anything, over A squared times by concentration of B. So concentration of C times by the concentration of D all over the concentration of A squared, because the molar coefficient becomes the power, times by the concentration of B. Now we'll work out units. Moles per decimeters cubed. Takes ages to write it all out, but it is worth doing so then you don't get it wrong. Moles per decimeters cubed times by moles per decimeters cubed times by moles per decimeters cubed, because you've got 1, 2, 3. And then we can cancel all of that and we're left with, I'm going to go through this step by step because I know some people aren't as happy with maths as others. 1 over mole per decimeters cubed, because this is still below the line, remember, and that's not a unit that we would use, so you need to bring everything above the line, and in order to do that you just take the inverse. So Kc, the units are moles to the -1 because you're bringing that above, decimeters cubed, so you get rid of that minus because you're bringing it above, you're taking the inverse. So the units in this case are moles to -1, decimeters cubed. Okay, now I've got one more to show you and then I'll move on to, I'll probably do another video to show you the next step. Okay, so the last one to show you, there is a slightly more complicated one which maybe I'll show you if I come across it. Okay, so we've got A plus B is in equilibrium with 2C plus D. So we're going to construct the expression again. Kc is equal to C squared times by D all over A times by B. So that's your equilibrium expression. Now let's look at units. So Kc is equal to moles per decimeters cubed, moles per decimeters cubed, moles decimeters cubed, 1, 2, 3, all over mole per decimeters cubed, moles per decimeters cubed. It's really important that you get used to working out these units for this topic and for other topics next year as well. So cancel everything that you can cancel. We're left with 1 moles per decimeters cubed. It's on the top of the line, so you don't have to do anything with it. So the units are moles per decimeters cubed, and that's the units of Kc. You'll get a number like 1.1 moles per decimeters cubed, and that's the units in that case. Okay, so I would like to just show you a reaction. This is the reaction that's listed in your syllabus that you need to know, and we'll construct a Kc expression for this reaction, and it's an esterification reaction between ethanol and ethanoic acid. So if I write it out on the board, I'll try not to use as much red because I know some people don't like red. So we've got ethanol and ethanoic acid. This is a really long reaction. I think I've probably not given myself enough space. And we make ethyl ethanoate. If you're not familiar with esterification reactions, making esters, it's because you haven't quite done it yet. So don't worry about it if you don't know this reaction. But you do need to be able to do all sorts of calculations if you're given this reaction in AS anyway. Sorry, in the first year in your mock exams. So long as you're familiar with this, it's fine. But if you haven't actually done this type of reaction, you don't need to know how it works yet. So we've got ethanol, ethanoic acid. This is called ethyl ethanoate, and we've got water. So question 1, construct the Kc, the equilibrium expression for this reaction. So you just do exactly as we've done. Kc is equal to concentration of ethyl ethanoate, CH3, CO2, C2H5, and don't forget the water, all over ethanol, C2H5OH. Doesn't matter how you write that, if you write the structural form that's fine, and CH3COOH, ethanoic acid. So that gives you the Kc expression for that reaction. Now you'll be asked to work out the units for that reaction, and the units here are going to be no units, because you've got moles per decimeters cubed, moles per decimeters cubed, moles per decimeters cubed, moles per decimeters cubed, and they are all going to cancel to leave you with no units. Right, in the next video I'm going to come back and I'm going to show you how to do some calculations involving Kc. So I will see you in a second.